risk is also in terms of, like you could say, environmental factors, like if the site or whatever the developer is building something that is in a coastal area or in an earthquake prone area or things like that. So, how do you basically look at mitigating these kind of risks? 3D printing, and which is, people are trying to scale that up as well. And there is automation and robotics for accurate rebar placement and various things like that. In fact, even sensors in concrete, so that you know exactly how much moisture. How do you see them as viable methods, especially in the Indian context? Hello and welcome to CQRA Quality Dialogues. Mr. Kunte and I were, in the earlier episode, discussing the life of structures. What should the ideal life of structures be? And we are really excited to now further explore this topic and talk about enhancing the life of structures. So, welcome again. This is your host, architect Shruti Hussain, and we are, of course, joined with the quality expert, Mr. Ujwal Kunte, who is the founder and MD of CQRA. And as you all know, again, CQRA is one of the leading audit companies in the country, and they're doing audits in construction quality, safety, and quantity surveying. So, looking forward to some more insightful, talks with you.
Sure.
I'll just start with these two particular incidents that, of course, you must be knowing, and maybe the larger construction fraternity also knows about. But they stand out because of the scale of failure of structures, and both of them are in Gurugram. This is by a prominent developer, and they were designing a residential scheme, and they had some, an external auditor come and audit their construction. And it was found that, there were major anomalies basically in the concrete. Too much of chloride, like you explained, then, the after effects of that on the reinforcement. And the company suffered majorly. They are spending crores in trying to, make good the kind of errors that they've made, and also in terms of buyback. So they're buying flats back from the customers. And second incident is like even more shocking, where the living room floors just collapsed vertically, of 5 floors, one after the other. And there were deaths. In fact, two residents in fact lost their lives. And the developer had to do an assessment of all the buildings in there, and they were eventually found to have too many snags and not fit for living. So it had to be, the people had to leave their homes. Basically, that's like a hanging sword on their investment and their homes, so to say. So when we see these kind of structure failures, and we're talking about life of concrete structures in that sense, how can engineers, developers, builders uh, sort of look at mitigating these kind of risks? So this is one, when it comes to actually looking at the processes, or the kind of material quality that goes into it. The second factor of risk is also in terms of, like you could say, environmental factors, like if the site or whatever the developer is building something that is in a coastal area or in an earthquake prone area or things like that. So, how do you basically look at mitigating these kind of risks?
The incident you mentioned, which happened in Delhi. So basically, it was problem related with the materials that went into construction. You know, there are
Mhm.
various things. Like I mentioned, how dangerous chlorides can be for a
Right.
RCC because
Hmm.
they corrode the steel.
Right.
So chloride should not come in concrete in either through cement, admixture, or even water. Now,
Yes.
construction water is a very important part of concrete. It hydrates
Right.
the concrete.
Yes.
And I recall that in those days, Delhi was facing shortage of water,
Okay.
and they had allowed use of treated water in construction. Now,
Hmm.
when you allow treated water, of course, it may be used, it can be used,
Hmm.
but then it should be tested. Water, it has to be very, very frequently tested. So the RMC plants were using treated water probably, and which had a lot of chlorides in it,
Okay.
and those chlorides had its impact. So within
Uh-huh.
a span of 6 to 7 years, there were corrosion cracks.
Okay.
Okay,
Hmm.
so I would say that periodic testing. One is when you are designing the concrete, you can do a lot of preventive measures, plus quality control during the construction process.
Okay.
And once the building is constructed, risk mitigation by engineers is to observe the cracks.
Okay.
All RCC structures are designed to crack, and
Right.
either. So if you find that there are structural cracks, then and mind you, there can be non-structural cracks also. So a qualified structural engineer can distinguish between the two. So you need a structural engineer's visit to the site to whether those cracks are structural cracks, and you have to observe how those cracks are growing in width, and the pattern of the cracks, and whether they are growing in length. So based on that, you can take some early measures. You could have probably, if a good structure engineer would have visited and observed, a collapse like situation could have been averted.
Okay. So, right, that makes sense that you have to timely keep on looking into the structure, and also that was pretty shocking, so to say, that that particular incident of using water in that time and the kind of effect that it has.
True.
So, these are things that a lay person who goes to buy property, either home or commercial or whatever it is, does not know, obviously, what is going into the construction process. So, is there a way for them to, kind of understand what they're getting into? And, are there ratings in terms of, quality ratings for buildings? And how can, CQRA kind of contribute in that, in helping the layperson kind of buy a property that is, worth its while, basically?
Yeah, very important. There are ratings available in most of the fields for finance companies,
Yes.
even restaurants are rated. So we thought that why a construction quality of a building where a person puts his lifetime savings should not be rated.
Yes,
So
very true.
CQRA has introduced quality ratings, which look into the design, the materials that go into it, the quality control, and finally the finished product.
Right.
So all these things are combined, and based on our experience of working in this field for more than 2 decades across the country, on variety of projects.
Right.
So we have compiled or developed this rating mechanism, and we are rating projects as A, the A plus and A plus plus. So the top 25% fall in A category. The top 10% fall in A plus category, and top 5% fall in A plus plus category. So we have designed this in a way that a buyer can, look at a property. If it is rated, he will know what kind of construction he is likely to get, because many of the defects are latent defects. They appear over a period of time. So all properties look similar when you are buying it. They're all new and well finished.
Yes.
So this is what we have done.
Okay, so that is a wonderful thing, in fact, and a very encouraging move where you can have sort of unbiased ratings, because we know how ratings also sometimes tend to work. So this is something that is really an excellent thing in terms of for home buyers. Uh, but going ahead, there are other issues as well that we see right now. There is this unprecedented level of construction that is happening. Urbanization is at its peak, not just in India, but even globally. So the kind of demand there is for construction of houses, for commercial properties, and even infrastructure projects. Um, that means, there's a lot of focus on speed, getting things done, which means that quality also takes a setback sometimes. So what are the other measures, in fact, that, can be taken so that people who are at the receiving end, they are kind of insured against all of this?
Yeah, because this in last 10 years the projects have grown in scale and time span also.
Right.
So it leads to a lot of less time being available for construction. And there are material controls that you are supposed to have, or the process control that you are supposed to have. They tend to slip on such large scale projects, or even simple practices like curing of concrete. All these get bypassed in favor of speed.
True.
So you need to have a very good quality control team at site, and you need to have a good quality assurance plan.
Okay.
Okay, so both these are very important, and it is at CQRA we look at both these things and guide the project so that the scale and the speed don't impact the quality of the project.
There are, like you said, when you kind of, look at a new property, it all appears the same. So you don't know what is actually waiting, what's in store. So is there any, insurance for home buyers against these latent defects?
Very interesting.
Mhm,
World over, there are
mhm,
many countries where such insurance is actually available.
Okay,
Okay, which is known
interesting.
as either IDI, inherent defect insurance, or latent defect insurance.
Okay.
So this latent defect insurance comes into effect after the buyer takes possession of the property,
Mhm,
and it can cover all major losses due to either structural defects, flooring problems related with flooring, waterproofing, electrical, facades for a period of 5 to 10 years. You know,
Okay.
so you have to pay a one-time premium for
Mhm,
this during construction. There are
Okay.
series of inspections during the construction process,
I
and
see.
based on those inspections, this insurance is given. And the buyer has got, if there's any major structural defect or
Mm,
any construction defect that appears during that period, he can recover the cost of repairs from the insurance company. So
Okay.
in India, it is being provided by Swiss Re now.
Okay.
So this insurance has come to India, and I'm sure in next few
Mhm,
years this will become a very common, kind of product in the
Okay.
industry.
I see. Yes, we can hope to see this becoming very commonplace. But this is something also retrospective. I mean, once the construction is already done. But now we'll come to our, main question in terms of how do you enhance the life of a structure in the first place? How can you kind of make it,
Last longer.
yeah, last longer? Yes.
So actually, when you want to make a structure last for maybe 75 or 100
Mhm.
years, it starts with many things. One is the geotechnical investigation. you know
Okay. Yes.
because the foundation is very critical.
Mhm.
you know and you when you do the geotechnical investigation, you're actually measuring presence of sulfates, chlorides in the soil.
Mhm.
So based on the soil properties, you're supposed to design a concrete, okay,
Okay.
that will
Mhm.
resist such degradation process.
Right. Okay.
Could be sulfates or chlorides.
Mhm.
So your concrete has to be designed with proper parameters to counter any such harmful elements that are present in the soil.
Right. Okay.
Secondly, you should have a good design. You
Okay.
design of a building, structural design, I
Mhm.
mean, is very very crucial for long life.
Okay.
Because if it is a little under designed, the
Mm.
structure is likely to crack. It will not show effect immediately, but over a period of time the structure will deflect and it will have cracks, and those
Mhm.
cracks will give way to moisture,
Mhm.
and then it will start corrosion of steel.
Okay. Yes.
Thirdly, you must have a very good quality control mechanism
Mhm.
at site.
Right.
Use of fly ash and GGBS
Mhm.
is highly recommended because they are known to resist chloride attack for
Okay.
steel.
Okay.
So they offer a better, the concrete made with fly ash and GGBS is
Mhm.
known to offer better protection to rebars
Okay.
against
Yes.
corrosion. Apart from this, there are various other things like good curing practices. Then sometimes choice of materials is also very important. In coastal areas, you could use corrosion resistant steel,
Okay.
or coated steel. So there are various things that you could do, and the best part is that
Mm.
after you have taken all these measures,
Right.
there are, as I mentioned in my last part,
Right.
that there are very good models which will
Mm.
establish that whatever you have done till date is going to give you a result,
Okay.
what is going to be the residual life of the building.
Right. Okay. Yes. So that That's like a very comprehensive, analysis, or like a plan of what one should do in terms to, enhance the building in the first place. And of course, there are other things that you've mentioned. We're also in an era where we are seeing a lot of technological advancements in terms of even the building technology, how a building gets actually built. So you have, various kind of concretes that are available, which are self-healing in that sense. So, if there are small cracks, they heal by themselves because of the additives or whatever there is in that. Then there are also, we know of 3D printing, and which is, people are trying to scale that up as well. And there is automation and robotics for accurate rebar placement, and various things like that. In fact, even sensors in concrete, so that you know exactly how much moisture, what is the temperature, what are the other things that you need to do. So, in light of all these kind of advancements, how do you see them as viable methods, especially in the Indian context, so that we have structures that, last uh, a good life, the structures that have a good life, and also sort of have a good environmental, responsibility in that sense.
See, of all the technologies you mentioned, there are certain technologies that improve the efficiency,
Okay,
especially the robotics and other parts.
right.
There are certain technologies like 3D printing, they will be used in niche areas,
Okay,
not for regular construction.
right.
You can construct a house very fast with minimum labor,
Hmm.
and probably you could get a house like you see in Walt Disney movies,
Okay,
very unconventional shapes and structures you can make in
right.
3D printing.
Hmm.
But for routine structures, the
Yeah.
technologies that are relevant is use of sensors. We
Hmm.
today structural health monitoring is coming up in a big way.
Okay,
So what we do is we embed sensors inside the concrete during construction.
right.
So, and
Okay.
there are variety of sensors that are available.
Mhm.
So they will tell you about deflections, about the heat that is being generated, the strains
Right.
that are
Yes.
being
Yes.
generated,
Mhm.
and these sensors can communicate outside and transmit information.
Okay.
So probably you could have bridges where these structural health monitoring systems
Mhm.
are put in place, and
Right.
if there is a risk to
Mhm.
the structure, either excessive deflection or cracking,
Yeah.
or
Okay.
so the system will itself give you a early warning.
Okay.
So these are some of the technologies I see coming in near future in India,
Mhm.
because they are not very expensive, commercially viable, and they will definitely result in a good ROI for the client.
Right. That is most important, how that ROI sort of looks on the
Correct.
balance sheet. Yes. So that was a, wonderful kind of, discussion that we had. A lot of topics covered, especially I think the takeaways that our viewers will have are very interesting, very useful, in fact, in terms of practice. And quality ratings, in fact, CQRA quality ratings, and the other aspects that are related with, enhancing the life of buildings. I'm sure all these are going to be very useful to our viewers. I hope you had a very interesting session as well. And thank you for joining us, Mr. Kunte. And
Thank you.
thank you again. Thanks.